I have implemented a simulation of charge in an elastic solid. The key point here is charge is spherically symmetrical. That means there's no north or south. All the wobbles have to go into the same direction when looking either from the inside or the outside, or looking from the outside or the inside, from everywhere. Okay? So let's take a look. First of all, let's look from out to in. I have placed several markers on top of a sphere, and you can see it rotates counterclockwise. Let's go around the sphere. You can see it's still counterclockwise. Counterclockwise all around. Let's look at the top. Still counterclockwise. The bottom, it's also counterclockwise. You could also see this when you move the camera to the center of the sphere and then look outside. Of course, then everything is reversed, right? So when you look out, all the wobbles are clockwise. Doesn't matter what direction you look, it's all clockwise. The other side, also clockwise. Now, spin 1/2 was different. In spin 1/2, we had the top and the bottom different. They were rotating in different directions. That was a precession movement. This is not a precession movement, okay? When we change the scene to minus charge, of course, everything is flipped around. So now the rotations when looking from the inside to the outside is counterclockwise. Even on the other side, it's counterclockwise. And then we can also move outside again and look at the markers that are placed on top of the sphere. You can see that the markers on top of the sphere also move in the same direction. They move clockwise, 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 and even at the bottom, clockwise everywhere. There are no discontinuities. The trick is how the quaternions transform the scene. For the spin 1/2, we were using the vertical axis to rotate, okay? This gives you a sort of a precession movement that emulates the belt trick. This is different. Here, the trick is to use the radial unit vector as the rotation axis for the transformation using the quaternions. That makes it spherically symmetrical.